Okay, what I wanted to talk briefly about today is an example of how the Benford Analysis macro, the Fraud Toolbox toolbar, can help you quickly identify suspicious transactions. What I've put together to highlight this is some S&P 500 data. I forget what day this was for. I've downloaded it quite some time ago, but what I want to run the Benford's analysis on is this column K, or the volume column. The reason I'm using this data is because Benford's analysis is supposed to work over a large random data set. And the volume data here would be a large random data set that we could run this analysis on. And I've run this before on this data, and I could see that it fits very well with what the expected Benford values are, and so that's why I want to use this data to demonstrate it. But this Benford analysis can be run on any numeric column, so the amount columns for a checkbook register or for a journal, for a set of books, anything that anything that has a numeric column, you can run the Benford analysis on to figure out whether that set of data is truly random or not. The idea behind using Benford's analysis for financial investigations is that if somebody were to try to defraud a company, the numbers that they would create to run through the books would not be truly random, because we as individuals, humans, cannot truly create a random set of values. And so something's going to stick out. If I continually run a check through a check register that I shouldn't be, the numbers that I make up for the amounts probably aren't going to be random. And that's why this works on financial data. But again, we're going to use this volume column here to demonstrate how Benford's works on a large random data set. What I've done is I've copied this volume column K, over to a different sheet. And the reason I did this is I think it works just a little bit easier if we have the numbers setting off by themselves. You don't have to do this. I think it makes the calculations a little bit faster and cleaner, but what we have here are a list of the volumes. What I wanted to point out is that there's 3 rows of data. This row 60, row 72, and there's a row further on down the line in which I was not able to pull out the volume data for the S&P 500 stock symbol for that day. So what happens is my macro will throw in these question marks, and it will show that I do not have any data for that. The reason why I point this out is because the macro is made to overlook non-numeric cells. And so what you'll see when we run this data is you'll see that the total data set is out of 497 instead of 500, because we only have 497 rows of data instead of 500. But what we're going to do is, I've already highlighted this row, or this column of data. I'm going to click on my Benford analysis. I'm going to click on my column here. You'll see it's going to pre-populate with row A, or I'm sorry, column A, row 1 through column A, row 501. Now what I'm going to do is I'm going to click on the first digit analysis, and what I'm looking for is I'm looking to count the number of times each digit appears as the leading digit. So I'm going to count the number of times that 3 appears as the leading digit, or the number 1, or the number 6. Benford had calculated that these leading digits should appear in a certain expected order in large random data sets, and we'll see whether these numbers actually appear as Benford would calculate them to be. So I'll hit my first digit analysis, and here's what I come up with. The number 1 appears, or should appear, approximately 30% of the time. We count that in our data set it appears 151 times out of 497. Again, that's because we have 3 rows of data that are not numeric. And the actual value that we calculate them to be then is 30.3%. You can see that's pretty close. When we go down through all the numbers here, 1 through 9, we don't include the number 0 because it's usually not a leading digit. But you can see what our expected values are, what our actual count is. Again, our total count is going to be the same for all of them, and what the actual value is of each of those numbers. What I did here was I had the macro create a quick graph. The graph provides a very quick, easy way for you to look at the numbers and decide which ones stick out. So the blue line here is the Benford value, what we expect them to be. The red columns here are what the actual volumes are. You can see here why I picked this data set is because it closely mirrors what the expected values should be, what Benford calculated them to be. And that's the reason why it works on this one. But what I want to do now is I want to go back to sheet number 1, and I'm going to run the Benford analysis over the second digit. Whoops, let me do that again. I have to pre-populate the column here. And we'll run the second digit analysis. And here you can see that the second digit of this volume does not exactly mirror what Benford calculates it to be. So you can see here, I'm willing to forgive a little bit of difference here in the 0 and the 1, and maybe the 4, 5, and 6, but you can see that maybe the 2, 3, and 7 spike quite a bit. And those might be numbers that we want to hone in for our suspicious transaction analysis. One more time now, what we're going to do is the same set of numbers. Again, we'll pre-populate my range here. I'm going to run on the first and second digit analysis, and this time what we're looking for is the number of times the number 31 appears, or the number 17, or the number 64, etc. And we can quickly calculate those as well. And we can scroll down on the bottom, and you can see quickly from the graph which ones spike and which ones do not. And you can see from our prior graph that the 2s, the 3s, the 7s tend to stick out. Well, here you can kind of hone in on which of those specific numbers actually stick out more than other ones. And so in order to go back and finally identify these numbers and investigate them further, what I did was I added another tool to Benford's analysis. This is what I call the Followup Tool. So for instance, if I want to go in and find the rows where the first and second digit is, say, 17, because the number 7 seems to stick out quite a bit, I can go ahead and, whoops, I forgot to pre-populate my column there. So let me go ahead and you can see what we've done is we've highlighted all the numbers that begin with the number 17. And so we can quickly look at those rows of data and figure out why the 17, or we can inquire into why the 17 sticks out. So here, if we go back to our initial spreadsheet, if I want to run the Benford's analysis over this, let's just go ahead and add in, I want to do K1 through K501. So I'll populate this numeric range here. And again, I want to figure out which of these are associated with the numbers that start with the number 17. And so I can quickly look at these and determine, in this particular instance, which of the S&P 500 stocks has a volume that begins with 17. Well, what you can do in a financial set of data is you can quickly identify, for instance, what the check number was, the payee, the person who actually authorized the payment, the date, everything that's associated with that payment, and you could quickly look into why that number is the way it is. So anyway, that's a brief summary of how you can use the Benford's analysis macro in my Fraud Toolbox toolbar to quickly identify potentially suspicious transactions. Please visit my website at fraudtoolbox.com. Thank you.